we've had 20 COPs, and what have we done to address climate change? Greenhouse gas levels are rising faster than ever. The extreme weather events are taking off. There's feedbacks putting more CO2 in. You know, it's like, okay, we're going to have another one. So is this really going to be a game changer? I mean, we're an innovative, intelligent species, but we're total idiots on the climate change issue.
All right, so we're sitting here in the University of Ottawa with research and part-time professor Paul Beckwith. Thank you so much for joining us. So let's start off just by getting a general overview of the breadth of study and research that you do.
Well, I look at the overall climate system and try to see how the different components are changing and how they interrelate. So, for example, the Arctic sea ice, we're getting a large decline in area and thickness and volume, so the white ice is being replaced by dark ocean. The snow cover over the land surfaces is also decreasing, so the whole Arctic is getting darker, so it's absorbing more solar energy, which causes it to heat up even more, and it's a feedback effect. The darker it becomes, the more energy it absorbs, the faster it heats up. So this causes Arctic temperature amplification. The numbers are a bit controversial, but usually quoted as 2 or 3 times. But actually, if you go to the high Arctic, it's warming, 5 to 8 times faster than the rest of the planet. So this is what this means is the Arctic's warming very fast. The equator doesn't change much, so it decreases the temperature gradient or change between the equator and the Arctic, and that changes the jet streams. It slows them down. They become wavier, and thus there's a lot more extreme weather events. Also, it's warmer, so there's more warming of the oceans, more evaporation, so there's more water vapor in the atmosphere, so the climate system is like supercharging storms and things. And then there's also other feedbacks in the Arctic. As we warm the Arctic, then we're melting permafrost, and we're also getting release of methane from the permafrost on the land, but also the permafrost on the seafloor. And methane is a very powerful greenhouse gas, so this can lead to very, very strong feedbacks, very, very large warming events. Alaska's been warming much faster than the global average, so it's drying out, and there's a lot of permafrost there. So we're getting these massive fires. We have over 300 fires going on in Alaska right now. So not only do these fires burn the wood, producing the CO2 and carbon monoxide and ash, which can go into the Arctic and darken it, but it leaves a blackened surface, which absorbs a lot more light. And it burns into the soils as well and removes that insulating layer over the permafrost. So the permafrost can thaw more, and also when it rains, the water goes directly down into the permafrost. So then you get more methane produced. So all of these feedbacks, all of these cascading feedbacks are a problem.
Oftentimes in the scientific world, we're dealing with both data and models. Could you explain kind of what the difference are and what the value are in both?
There's lots of groups around the world that have these very sophisticated computer models. First of all, you run them backwards to see if they can replicate what's happened in the past, and then you run them forward and try to make projections as to what's going to happen, and they're based on physical equations and things of the system. And these models are used a lot by the Intergovernmental Panel on Climate Change, but the models are under-predicting big time the actual observed measurements of what is actually happening. For example, in Arctic sea ice decline, the latest models are showing that the sea ice may be gone the end of the melt season in 2040 or 2050, something like that. And if you look at the data, the volume of sea ice dropping down, if you follow that trend, it's likely that there'll be no sea ice before the end of this decade.
So sometimes with the general community, people think, okay, sea level rise. Well, I don't live near the sea, so how does that affect me?
I don't think it has trickled down to the public too much. I mean, if the public and if the politicians actually realized the extent of the changes that are happening, I think they'd be quite terrified. The changes that are happening are extremely rapid. I would say abrupt climate change is underway. Like, you know, we're just at the early beginnings of very massive changes, and we're already seeing a large increase in the frequency, severity, and duration of extreme weather events. For example, torrential rain events causing flooding, droughts, for example, such as the California drought, the South American drought. Many parts of the world are undergoing extreme precipitation regimes, either droughts or flooding. People expect that California, you know, it's a long drought, but eventually it will end. Well, it may not. Okay, it may not end. It may go on for years, for decades. We may have mass migrations of people out of California. If you go to the northern Pacific, the water is extremely warm. You know, vast regions of the ocean are 4 or 5 degrees Celsius warmer than normal. It's causing lots of marine life kills off the west coast of North America. The whole system seems to be reconfiguring. We're going into very unknown territory.
In the international community, there's been growing talk of 2-degree rise in temperature is the absolute threshold for what our planet can withstand before abrupt climate change takes place. Some of your research has been examining that. What have you found? Well,
since about 1750 or so, the beginning of the Industrial Revolution, since that time frame, we've had 0.85 degrees Celsius of warming. 0.6 of that 0.8 or so is in the last 30 odd years. Now, what do we have with that 0.8 or 0.85 degrees of warming? We have a large increase in extreme weather events, as I was mentioning. You know, the Arctic has reflected about 52% of all the incoming solar light on average a few decades ago, and now it's down to 48. So this is a huge drop because it's over a large area. So all of these things are happening with 0.8 degrees. So to tell me that you know, we can take 2.5 times that warming, I don't know how that's possible. It doesn't make any logical sense to me. You know, that 2-degree limit is kind of a number that has been out there for a long time, but it's not really a scientifically derived number. Now, there are lots of people like James Hansen and other climatologists that are now saying 1.5 degrees is the highest limit we can go, but even 1.5 degrees is almost double what we have today. So another thing that's important is, you know, what time period does that warming occur over, right? If that 2 degrees occurs over, you know, a long period of time, you know, 50 years, 100 years, then okay. But if it occurs over a decade or less, right, then it's a rate of change that is very, very important, which nobody talks about. So if we lose the sea ice this decade, in September, then the extreme weather events are going to increase at least an order of magnitude 10, 20 times. Is mitigation still a topic worth discussing, or are we now in the point where adaptation is the main? No, I mean, you know, how do you adapt to, you know, a rapid rise in sea level that floods out your city, right? You have to move to a different city. Like, you know, you can only adapt so much. I mean, we have to go full speed ahead with mitigation. You know, we have to slash fossil fuel emissions, not by 2100, which the G7 just talked about, not by 2050. You know, we have to treat the climate mayhem that is occurring as a global emergency that threatens our actual existence on this planet. We have the technology to go to a renewable, pretty much a renewable society. The prices of solar and wind and all of these things are plummeting as we hit the economies of scale that we're reaching. and the growth rates are enormous, but we could ramp those up much faster. I think there'll be a tipping point in human behavior very soon, and people will actually go to full-out panic on what's happening and demand that rapid changes be done, treating it in an emergency fashion. I mean, that's my view, and I think we also have to really seriously look at ways to remove carbon dioxide from the atmosphere to get levels lower, and also look at ways. I think I don't think we want an ice-free Arctic. I think we need to try to cool the Arctic.
Does this technology exist, and if so, what's stopping it from being utilized?
Well, there's a lot of research on the technology, but in terms of, for example, carbon dioxide removal, so we have slash emissions to zero, we need to start removing CO2 from the atmosphere quicker than it's going in. People are looking at a lot of different techniques. For example, olivine is a very common mineral, and if you crush it and you'll get dust and large surface area, then that will absorb a lot of carbon dioxide. So basically you can accelerate the weathering process to remove carbon dioxide. People are also looking at things like biochar, where you actually burn organic material in the absence of oxygen, and then you get this charcoal-like substance, and then you can put it in soils and so on. So the organic material in that form won't decompose quickly. So that'll be a way of storing more carbon in soils. If you use iron in the oceans in parts of the southern hemisphere, you could get huge plankton blooms, which then would absorb carbon and remove it from the atmosphere and bring it down to the seafloor. I mean, ocean acidification is also an enormous problem with the elevated CO2 levels. So carbon dioxide removal, there is research, but it's nowhere near enough. We need to do far more research on this area. Another area is solar radiation management, and that's the idea of, for example, putting sulfur dioxide in the upper atmosphere to reflect some of the sun's rays to cause cooling. This happens when volcanoes go off. Now, there's lots of sulfur that comes out of coal burning smokestacks. It doesn't make it up high, but there's lots there. The amount of sulfur to put in the stratosphere would be much lower. Of course, these are very controversial ideas, the solar radiation management part, but the carbon dioxide removal is not as controversial. Planting more trees and having less deforestation is another important way.
You've been a part of the United Nations framework on climate change. Could you maybe talk a little bit about how that experience has been for you?
Yeah, so I went to the COP20 in Lima, Peru, and I was involved in 4 or 5 different press conferences. But the feeling I got is, it's a big convention, there's booths set up, there's lots of people wandering around talking, but the sense of urgency just wasn't there. And I would say mostly with the public and politicians, it's still complacency. It's still not a recognition, or whether by not wanting to think things are a problem, or whatever psychological things are going on, I'm not sure. But I think we'll go from that state to a complete panic state. And then after they go through the panic stage, hopefully things settle down and we can actually take strong action to do what we can to reverse things, or at least slow things down, because society is going to completely change. I don't understand, I cannot fathom why the scientific community isn't far more vocal about the risks and the threats that we face.
It seems like in academia, but especially in some of the scientific fields, there's a lot of silos, and people aren't necessarily willing to look at things in more of an interdisciplinary kind of way, because they,
yes,
and sometimes the rationale that I've heard at least is, oh, well, I can't become an expert in all of these, so I can't consider this, I can't consider that. For you, what's the value of looking at things interdisciplinary and using other people's research rather than necessarily like replicating every bit of it? Like what's the value of piecing things together? And also, why is it important for scientists to communicate well? rather than just publish and be satisfied?
You know, the science is definitely siloed, and the higher you get, the higher the levels are, you know, masters, PhD, postdocs, research, you become extremely specialized. You know, you become so specialized, you want to know about your niche, everything that's been done in the field, and then do some research to extend what you get. So you're very, very caught up, very, very windowed into that field, and this is how the universities are based. This is how science is based, you know, it can be very useful, but there is a large time lag. For example, the IPCC reports will only take peer-reviewed papers that have been out in the literature for 2 years, and it might take a year to get through the publication cycle and a year to do the data. So when the report is fresh off the presses, the data, you know, it's on stuff that happened 4 years previous. It can't have anything more current. You know, and this is okay when things are changing slowly, but the climate is changing so fast. We're getting lots of these new phenomena occurring, and they won't be in the peer-reviewed literature for years. Collectively, as a society, we can do a lot, but there are a growing number of people that are throwing up their hands and saying, you know, that's it, we're finished. I mean, extinction, we're in the 6th global extinction, and animals are, you know, the extinction rate is a couple hundred species a day when the natural rate is, you know, 100 times, 1,000 times smaller than that. I mean, our whole political system is, you know, the money and the power structures are just not wanting to recognize the reality of what's happening. So I would hope that we'll reach a point where that would change, and that's this tipping point in human behavior. But we can't wait forever. We can't wait. In fact, we can't wait a decade. We can't wait. We have no time. We've used up the time. We have to act as soon as possible, as soon as we can, and pull out all the stops. You know, we're breaking temperature records around the world. I mean, Europe's in another massive heat wave. We had a massive heat wave in Russia, which wiped out 40% of their grain crop in 2010, and that caused food prices to spike, which can be related to the Arab Spring. How much more do we need to know? We know enough, but we need to put far more. We need to treat this as something that can take out civilization. We need to treat this as the threat, and then deal with it using our technology, using our innovation, using our resources. And you know, the threat is not, you know, ISIS or terrorism. I mean, look at the statistics. I mean, you're more likely to be killed by a toddler in the US than by a terrorist.
We're here in the nation's capital, and it's been widely covered in the news that scientists and researchers under the government have not been allowed to fully explain their research to the public. How does this play into the Canadian sensibilities around climate, and how do we change the conversation?
There's definitely a problem in science in Canada. I mean, we had 3,000 scientists go on a march a few years ago to protest the cuts and the muzzling. And I mean, if you're a media person and you want to go to, you know, you want to go and get information on a particular topic, you can't talk directly to a scientist. That you have to go through, you know, a whole set of bureaucracy to get permission to talk to somebody, and then when they're talking to you, often there's a monitor to watch what they're saying, and it's draconian. I mean, what it means is that we base a lot. The government bases a lot more of their decisions on ideology, and it's a lot more difficult for people to contest the rationality of such a decision because the science isn't there. There's groups like Evidence for Democracy that have sprung up. There's lots of, you know, attempts, but you know, to try to change that situation, but they've mostly been futile.
It's been said, generally by our Prime Minister, but probably some other groups as well, that because the population of Canada is so small, and by scales our industry isn't as large as some other countries that because Canadians aren't contributing the most, we don't need to do as much. Do you think that we need to lead more and on an international scale? Do you think that we have more of a responsibility to do our part and maybe even go above and beyond?
You know, in many areas of international and foreign policy in the past, Canada has been a leader and pulled far above our weight. You know, for example, we used to be known as peacekeepers of the world. That's certainly changed. Basically, our dollar has become a petrodollar. Jeff Rubin, CIBC, used to be a CIBC World Markets economist. He's written 3 or 4 books now, and his latest is The Carbon Bubble. And he talks about how this is a very economically unsound policy for Canada. Some of the big brokerages in the US now are saying that they're expecting the Canadian dollar to be about 70 cents. Our GDP has decreased, and that's expected to continue, and we'll be in a recession towards the end of the year. And to come from a government where the leader is supposedly an economist or has economic training, it's not a rational policy at all. We need to be expanding our renewable energy production as fast as possible, right? We need to get serious about ensuring that we stay on this planet, because if we don't do anything, business as usual, I don't think there's a lot of hope for a future.
Well, thank you so much for this sobering discussion, and we really appreciate the work that you're doing and the time that you spent with us. So thank you very much.
Thank you.